2, 1.
Alright guys, in lesson 2.3.1 we're going to talk about graphing linear inequalities. It's very similar to graphing linear equations, just has a couple of extra steps. So, here we go. A linear inequality in two variables has a half plane as a set of solutions, or since it's greater than or less than, you're going to have more than one possible answer. It's not just going to be the dots that are on the line. It's going to be anything that's above or below that line as well, depending on whether it's greater than or less than. A half plane is a region containing all points that has one boundary, which is the straight line that continues in both directions infinitely. Right? So you see the shaded half plane here. That's what we're trying to show you. Okay? To determine the solution step, first you graph the inequality as a line. In other words, you're going to graph it like it had an equal sign. And then we're going to do a couple of things to show that it's an inequality instead of an equal sign. So the first thing is less than or equal to, or greater than or equal to, greater than or equal to, less than or equal to. Those are called inclusive, which means they also include the boundary line itself. Okay? You're going to show that with a solid line. Okay? Right here. Use a solid line when graphing the solution with inclusive inequality. In other words, greater than or equal to, or less than or equal to. And it's got the or equal to part. Right? When it doesn't have the or equal to part, which is greater than or less than, it's called non-inclusive, which basically means you cannot include that boundary line. That boundary line is where the equation, where it would be equal to. And since it's just greater than or less than, it cannot actually be equal to. So points that are on that line do not work. Okay? So to show this, we use a dashed line or a dotted line. You'll see that. So the points that are actually on that line would not be solutions if it's non-inclusive. Right? So example 1, graph solution to the following inequality. Y is greater than x plus 3. Alright, so I've already got sort of graph, or got my graph set up here. So I'm going to graph the line just like I normally would. Okay? So I start at 3. And then I'm going to got a slope of 1, so up 1, right 1. Now this one kind of already doesn't really need a lot of help from me, but I'll do it anyway. So what you can see here is that you got a line going, you got an equation of a line going, and then it's greater than, not or equal to, just greater than. Which means we cannot actually include this line, so we use a dotted line to show that. Okay? Your dotted line, you have to tell me that it's dotted, you have to show me that it's dotted. Or dashed. Okay? And try to draw it to demonstrability. And then we have to decide where to shade. I think of it like this. Are you going to shade above the line or below the line? Above is up here, below is down here. And it's very simple. If it's greater than, you shade above. If it's less than, you shade below. But always make sure that your Y is on your left side. Always make sure when you're doing that, the Y is on the left side and all the other stuff is on the right. It's set up like this. That's slope-intercept form, right, that we use to graph. And you can just look at the symbol, greater than shade above, less than shade below. So this is greater than, which means I'm going to be shading all of this up here. And you do not have to do a perfect shade, okay? Just enough to show you that you understand everything that is above that line. All right? Next one. Next example is y is less than or equal to negative 3x plus 7. So we're going to start at 7. Down 3, 1, 2, 3, right 1. Down 3. We'll go one more time. Okay. This time we have less than or equal to. In other words, it's included. Right? So we got to draw our line. This time it's going to be a solid line because it is included. It's inclusive. Okay? And now I need to shade either above or below. Just like before on the previous example, I'll look at whether it's a greater than or less than symbol. This time it's less than, so I want to shade below. So now looking at this, okay, looking at how this is set up, you have above the line and below the line. I tend to think of it like a ladder leaning on a house. If this were a ladder leaned up against a house, where would you climb up? You always climb up the above side, right? The above side is over here. That's the way, because the ladder's leaning on the house. You wouldn't climb up the underside of the ladder. If you can't visualize that, just try to think about which way it's leaning, and then something being above or below that. So this is the above side, this is above, and over here, that's the below. Okay, this is also below. That's all one side, and this is also above. Okay, another thing that some people do is they'll find the y-intercept, put their pin on it, and they'll say, okay, I need to go down from there, so I need to go below. That's that way. That's this side. So shading. Sorry for the pin noises there. All right, so there's that. Okay, now let's move on to word problems. Okay, a company that manufactures MP3s needs to hire more workers to keep up with increasing orders. Some workers will be assembling, so I got workers that are assembling, and others that will be packaging. So I got my group of workers split into two groups. Okay, I don't know how many of each, but I know they got two separate groups. The company can hire 15 total employees, right? No more than that. No more than. All right, so that means that if X is the number of people assembling, so X is assembly and Y is package, then those two things put together would have to be less than or equal to the total, which is 15. Okay, so I want to graph that. The first thing I need to do if I'm going to graph that is I need to get it in slope-intercept form. So subtract X, and we get Y is less than or equal to negative X plus 15. Okay, now that I can graph. And here we go. I got the X coordinates and the y-intercept. Again, that's Y is less than or equal to negative X plus 15. Okay, so I started at 15. Started up here at 15. I got my slope down, one right, one down, one right, one down, one right, one. So we get our X-intercept here. Now, the other thing I'm going to point out is this. If we're hiring people, X must be greater than or equal to 0. Y must also be greater than or equal to 0. So we have what you would call a restricted domain because of the situation that we are graphing. So it's less than, so we're going to shade below this line, which is this area, right? We're going to shade all this, but we have to also be greater than 0 on the X or on the Y values, and also greater than 0 on the Y's, on the X values, right? The X's have to be greater than 0 and the Y's have to be greater than 0. But altogether, it has to be less than your line. So we're talking specifically about this region in the first quadrant that is below that line. So it's important to understand that it will not always be a shaded region that is either just above or below. You may have multiple equations going on, or multiple inequalities. This would actually be called a system of inequalities, which you'll get more of in 2.3.2. All right, that's all the examples for this one, guys. I think this is a relatively easy lesson, but it's going to lead into 2.3.2. So make sure you take some time to go over these notes.